to Dr. Hansa Shingrakia and Dr. Poundwala and Dr. Khare for having me here. I really appreciate the activities done as a part of IEEE Education Week. At IIT Jodhpur, we recently have started a new center, which has evolved from the education technology vertical, and it's called, as Dr. Khare said, it's called Center for Education and Technology for Education. And um, even the national education policy uh, focuses, or rather emphasizes, on the need for educational innovations to make education more exciting, more engaging. And one such area which we have been exploring is game-based learning. I understand that it is somewhat controversial because not everybody accepts games as a part of serious learning, but there are serious games which are very helpful in changing behavior of people. And one such change of behavior is learning a new concept, right? And so the objective of my talk today is just to give you a glimpse of what is possible through game-based learning, and the rest I would leave to you and to your judgment if you feel such an approach might be useful in the courses that you are teaching currently. So what I'll do is, just to save bandwidth, I'm going to keep my camera off for the duration of the talk, and I'll keep turn it on uh,
No issue.
at the end. Right?
Yeah, sure.
And if you have any questions in between, please feel free to put them in chat, and we'll take them up at the end. So if you look back at your childhood, when we were growing up, we all were growing up, games, not just for us, but for any child, in the sense, games are extremely important, right? They are this activity which doesn't, the time flies like anything, and we don't realize how fast the games period is over, for instance. Or we would go out to play, whether it's indoor games or outdoor games. Once you start playing a game that you really like, and it's keeping you engaged and engrossed, time flies, and you can just continue to play this game for as long as you want. uh, as time has passed, a lot of the game activities have now changed into video games, and we have games on our cell phones and tablets and desktops. And uh, no matter what the age of the person, in today's times, these games, these mobile games, or video games for that matter, are so addictive that person the addiction is not just limited to kids these days, right? It's from teenagers all the way to octogenarians, who are, once they get hooked onto a game, they are just hooked onto that game. So what is it that makes these games so successful? In the sense, what is it that makes you continuously just mindlessly go on, like swiping, making three candies align to each other, or just there's a character that's going and going and running and running and running, there's nothing happening as such, except for the thrill, and except for the adrenaline of continuing and having that achievement. So there's a major difference between work and play, as we have seen throughout our childhood and growing up. Play time is a separate time, and study time has to be a separate time. That is what has been inculcated throughout school, college, right? And but still, the kind of devotion that one would give towards playing a game is not the same that people generally would give towards work or towards study, for that matter. So the idea is to bring in some elements of game and gamification into everyday education, and how that might help in change in behavior. So what is it that makes the games successful? Essentially, it is that it makes the player feel accomplished, and there is no fear of failure. Like, it's okay if you fail in a game, your game is over, or um, do not complete a particular level. You actually feel more excited to play that game again and do it and complete it. So that feeling of accomplishment when you actually complete a game, that is what makes the whole process of playing anything so exciting and so inviting. Now, gamification has already been established over several years, I should say a couple of decades, in changing behavior of people. So it has been already used in different settings. So what exactly gamification means? It means a combination of game design, game dynamics, and user experience, especially in settings which are non-game settings, like where you would not expect a game, where it's a serious setting. uh, there, if you bring in game elements and game dynamics, or game mechanics for that matter, and make the whole experience fun, and you bring in some more engaging elements, you apply them to real world activities and actually have some effect on the experience. That is what is essentially called gamification. Now, gamification is different from game based learning, and I'll come to that in just a second. The important factor about gamification is it is more human focused. When somebody is trying to teach you something, there is a certain process that follows, right? This is A, then this is B, and this is C. uh, it is essentially explaining the functionality of the process. But if you bring in element of gamification, it becomes more human focused. And what is the meaning of human focus? You target the core motivational drives that make a human being do something, that make a human being want to do something, right? That is what is called motivational drives. What is it that motivates a person to do something or not to do something? So those human focused drives are what gamification and game based learning essentially target. And one such example of such a network is given by Yukai Chao, and he is a pioneer in the area of gamification. If anybody is looking to learn about gamification, I would strongly suggest the book called Actionable Gamification by Yukai Chao. It's also available as an ebook. So Yukai Chao talks about this Octalysis framework, where this is a framework where he has developed for particularly targeting 8 core drives. So he says there are eight aspects or 8 drives that actually make a person want to do something. So having an epic meaning, like larger than life meaning in a game, the feeling of feeling empowered, having some social influence, like having some factor of prestige among your peers, some unpredictability. It is the uncertainty of certain games that make them more exciting. Is the fear of losing something, avoidance, or not getting something enough, or losing something, right? Then owning something, like owning points, owning badges, owning leaderboard positions, or some perks that come with it. And essentially the sense of accomplishment, like you've completed something and you are the hero uh, of that story, and you've accomplished saving, say, the planet or something. I'm just giving you an example of a random game, right? So essentially Yukai Chao talks about these 8 core drives, and he says these are what largely could be categorized as what makes a person want to do something, right? uh, Here, if you look at this octalysis diagram, on the top half, we could call these white hat drives, as in these are sort of positive drives, and the bottom half could be called black hat drives. These are negative drives, in the sense they make you feel negatively. They do not give you a positive feeling. They make you want to do something, but they are negative feelings, while the top one can be considered as positive feeling. They make you feel positive about something. We could also look at them from if we look at the left and the right hand side, we could talk about intrinsic and extrinsic motivation. So if you look at the left side, right, and these are like meaning, accomplishment, ownership, not having something enough, or the fear of losing something. These are uh, motivational drives which make you do something for the sake of others, like what will others think about you. And that is not something that you want to do yourself from within. But if you look at that, that is what is called extrinsic motivation. These are guided by external factors. But if you look at the right hand side, it talks about empowerment and meaning, and the excitement of something being unpredictable. These are what you internally would be motivated to do of something for. So these are called intrinsic motivation drives. So it is not that everything that games push for are all internal intrinsic motivations. It's a balance of extrinsic and intrinsic motivations. Now, why I'm talking about this is because the games that I'm going to show you later are focused on, like, or rather evaluated on this framework. That is why I wanted to present to you these motivational drives. And gamification already has had a proven effect in changing people's behavior in terms of marketing, sales, in healthcare applications, in various behavioral changes for, say, environmental awareness or sustainability education. It has also been used uh, adequately, like abundantly, in K-12 education, but not so much in higher education. Some examples of successful gamification: very very simple thing, like when eBay started about, like, maybe 1.5 decades ago or 2 decades ago. The simple thing that eBay did to bring in element of gamification was to bring in bidding. Like, you would post an item to sale, for sale, and people are going to bid against each other. So it's okay, there were times when people were willing to pay extra just because they wanted to win the bidding war, right? So just because it made them feel accomplished. And if you sold enough, you would get certificates, like simple certificates. They don't have any value, but it would make a person feel successful and accomplished, that okay, I got a yellow star, or I got these many stars or these many points. Another very common example which you are still susceptible to is like credit cards, where you want to spend more on credit cards just for those reward points which you can encash later, right? That is again an element of gamification. Another example was this power company, which was trying to, Power, which was trying to basically try and reduce the consumption of power in a certain neighborhood. And doing awareness programs did not really help. But the moment you start showing somebody a comparison between your home and your neighbors' homes, that is when the competition started. And people were like, okay, okay, I'm staying here, but that person, my neighbor, oh, look at him, he's spending so much on power, and I'm trying to save a lot of energy in that way. You also show efficient homes, like on an average. So then you'd start targeting how to reach this level of efficiency. So simple thing like comparison and social influence actually helped people achieve a change in behavior. So while these are all examples from marketing and sales, gamification has had a significant impact on education as well. And we have seen various examples like Khan Academy, which has everything. All the tutorials are all free of cost. And people can watch them, people can answer questions and see their position in the leaderboard. There's another platform called Quizzes, which actually helps you create like Bonvita quiz contest kind of quizzes, which you can conduct in your classroom right after the class is over, just for like few minutes. And it gets students very excited, because the animations and the sounds that come, it feels like a context, and it makes them excited. Duolingo is another very, very popular platform for learning languages, where you see your position in the leaderboard every day. And I have seen people like waking up in the middle of the night to see that, oh, my position has fallen to position number 3, and I need to go back to position 1, and they're just working and working and working hard. I should not say working, playing and playing and playing to reach that position. Uh, it's a very very effective tool to teach someone a new language, that is Duolingo. And then Classcraft is basically a learning management system which you can integrate with any of your LMSs. And it puts students into this whole story, into a fantasy land, where there is a quest that you need to complete, and that quest essentially is the assignment that you have given, right? So essentially gamification in in education is like inviting people to join, the good fight against boring education. But the tools to implement gamification are somewhat limited in today's time, at least at the level of engineering education. um, the difference between gamification and game based learning: while gamification means just gamifying an environment, right, through you bring in elements where people feel competitive, they feel excited, and there is some element which deals with all those 8 core motivational drives that I showed you earlier. Game based learning, on the other hand, is different, because in game based learning, the idea is to teach a particular process or a topic through games, through an actual game. Like the entire game uh, is based on the process. The say playing that game from end to end would teach the player a particular idea or a particular process. And the advantage that game based learning offers is that because you are so immersed in the game and you are interacting with all the elements which are supposed to be fun, and through this idea of role playing, and you have all these conflicts and obstacles and the accomplishment that you have, the important thing here is that the learner has the freedom to fail and relearn, right, until the concept is clear. We do not give students this opportunity when we evaluate them only through assessment, because there, if they get an answer incorrect, if it's wrong, the points are deducted, and then everything becomes about marks and scores and grades, right? But if a topic is taught through a game, the the fear of failing or fear of losing points or scores is completely removed. And because you can play a level multiple times until you are successful, uh, it gives it releases a lot of stress from the student, at least from the point of view of learning. And essentially, game based learning promotes active learning. There's a lot of literature in the past decade about various aspects of engineering education or other disciplines that have shown some effective outcomes based on game based learning. So there is study that showed that there's an increase in attendance, people completed their assignments more punctually, they were more engaged. This particular course paper is about a Python programming course. So there they actually noticed an overall academic increase in academic performance as well. But that is not always the case, because there is very less literature, and this is one such literature that actually shows an increase in academic performance. But that is not a universal case. Game based learning may not really help people perform better academically, but it is the process of engaging with the learning material that actually is proven to be improved using game based learning. So this is another paper that talks about simulation games, where students really preferred that over conventional study. There's a very good review paper by Bado in 2019 that shows that more than 87% of studies that he reviewed actually showed that there was positive cognitive or affective outcomes when it came to integrating games with the process of teaching learning. So it is not that games are being proposed to replace conventional teaching, but they are meant to just serve as a supplement to existing teaching process that somebody may be following, right? So just on that note, because I teach a first year course on basic electronics, introduction to electrical engineering rather, and I have seen students are, since in today's time most of the topics, even advanced topics, are sort of covered in plus 2, but not all students go through them very seriously. And while basic things like circuit laws and theorems and diodes and Zener, all these are very very obvious to them, but when it comes to slightly complicated topics like bipolar junction transistor, where you need to go through a lot of information first, absorb a lot of things before things actually start making sense to you from an application point of view. So that is where we took up a couple of research questions, and I wanted to find, can gaming storyboards be how can they be defined for different gaming genres to teach or reflect topics from technical areas, like for example introduction to electrical engineering. And how can the effectiveness of these games actually be validated? How do we say a game is successful or not successful? Because not all games are successful, right? There are like millions of games on Play Store or online. Not all of them are very popular, not all of them give a very good experience to a player, despite having really high-fi, very sophisticated graphics. So it's not about graphics all the time, it is how the storyboard is defined. And one very essential aspect of defining a storyboard for a game, especially from context of learning from teaching an engineering topic is to define learning outcomes first. Because what exactly do you want the player to learn from this game? It should not be for passing time. It should not be a recreational activity just to distract you from learning. It is supposed to, at the end of the game, like how in curriculum or courses we have learning outcomes defined, right? At the end of this lecture or the end of this lesson, student will be able to do this and this. That's how we define the outcomes. That is how the outcomes of a game should also be defined. So while normally this selecting of these topics would be done by taking a survey from the players, like from the students, but as I have been teaching this course, I had been for a few terms. Um, from my observations, I noticed that two areas where students really needed a little more help was, one was Zener voltage regulator. While they knew how it works, but how exactly to design a real world application with Zener was kind of very theoretical to them, not from a, it was not a very application oriented exercise for them. And the second is bipolar junction transistor. I'm sure people here are already familiar with this, with these topics. People even who work in signal processing or any allied area, these are very basic topics from engineering. And they are basic for faculty members, but they are not basic for students. And like I said, BJT requires a lot of information before things start making sense. Like how exactly can you use BJT to make an amplifier or to make a switch? Lot of information is needed. So it is difficult to retain students attention for such a long time. So these are the two topics which we chose and thought, let us try supplementing the regular classes with a game which talks about these topics. So we developed two different games and we use the Octalysis framework to theoretically validate them. So what is the design process that we followed? So the team essentially was second and third, first, second, and third year students. We have an engineering design project here where it's a non-graded course, but there are 6 design credits that students need to earn. So this was essentially a design project with two groups. So the first stage is planning, right? So to identify who are the target audience. So we thought this is for first year engineering students. Then defining what will be the outcome of this game and what exactly are the objectives of this game. What should be the storyboard? What are the tasks that a player should have to do? What are some game elements that we will bring in? Like what are the obstacles? How the story is going to progress? Where are we going to place questions? Where are we going to give points? Where are we going to put challenges or obstacles? Where will we give some element of surprise? So all those, the placement of all those game elements was then decided. What would be the platform, whether it should be a web application or a standalone application? Then do we have the budget and who's actually in the team, right? This is the planning phase. Then we worked towards pre-production, where once the storyboard is ready, then the UX and the UI for each of the scenes is then developed. Then because a lot of the progress of the game has to be validated, right? When, like, if a player is going ahead, if they are doing some action correctly, whether it is correct or not, that has to be validated at the back end. So the back end validation, how the character should look, how the character should move around, how the hurdles should be modeled, all these things had to be then done. Once the pre-production was over, then we moved to theoretical validation. The game is already developed, but we are still testing it. And so this should not say in progress. The development is already done. Wireframing and then authentication, various tools. Unity is the engine that we use to develop this game. And characters were made on Blender and some libraries from GitHub and Visual Studios were also used. I'll show you what the game is about. So we are currently in this phase where we've got some feedback from students, but we are still analyzing the scene by scene uh, um, experience of the players. And the two games essentially were, the first one being Circuit, we called it Circuit Maverick, where the outcome was supposed to be that the player at the end of the game should have the ability to design a voltage regulator using Zener for a given specification. The specification being for the scope of the game: efficiency, regulation, and the power rating. And the key factor here is that person should use standard components. They should not give theoretical circuits, as in you can make a circuit meet specifications in theory, right? Like having a 10-volt battery, but from where are you going to get a 10-volt battery in the market? You can't. You have to keep it as 9 or 10.5, because the AA or AAA cells would be in multiples of 1.5. So the use of standard components from a real world perspective was the key factor here. People know how to make a circuit using a Zener diode, but to do that using standard components was the main challenge. And it was also something which was kind of ignored by the players at first, and once they got penalized and they had to do it all over again, that is how they kept it in mind later. That is how the learning went. This was the team of students. They are from different departments, from mechanical and computer science, who worked on this project. I'll not explain in detail the storyboard, but just give you a story in general. So there is a boss, and okay, I'll rather explain it to you in the walkthrough directly of the game. So here is a walkthrough of the game. The basic idea is that you log in first, and we have kept this exclusively for IITJ students at this point. Once you log in, you are essentially, the player is the circuit designer. You can choose your avatar and set your name. uh, you are essentially a design engineer, and your boss approaches you and says, we have this really urgent project where uh, uh, somebody, a client, is about to launch their product, and the only thing they don't have is this voltage regulator for their gadget. And these are the specifications of the gadget. It should precisely have this much volt. It should have, this is the maximum power rating, and you should be able to do this with uh, components that are available in any hardware store or an electronic store, right? So after understanding the requirement, the player is essentially supposed to first design the circuit. So this is a simulator where the player should bring in elements. So all these elements that you see on the screen are designed from scratch by the students of this engineering design project. So you bring in a battery and you put in elements. Some of you may be familiar with the Fallstack simulator, um, which is also a circuit simulator. So the backend of this is similar to the Fallstack simulator. You components are available. The person should be able to connect the circuit and then test the circuit whether the requirements are being met. Once the circuit is simulated, then whatever components are used here, they should be approved by the player, and then the player needs to actually go to a store and purchase these components. The time is limited and the budget is limited. How you visit the store, whether you walk to the store or whether you take a cab to the store, depend would actually change how much money you have with you. The final score is going to depend on how much money you have left and how quickly you were able to complete this task. So once this is simulated and it is tested, circuit is valid, the person proceeds and then goes to the map. You have to choose the nearest store, um, and how much it will cost to reach that place. You reach the store, you've got all these elements placed on the shelf. You have to ask the shopkeeper, rather have a shopping cart where you choose the correct amount or correct values, right? And at the end, make the payment and go back to the office, go back to your tinkering lab, where you're going to physically, means physically as in you're going to virtually assemble this or tinker this circuit. So these libraries are taken from GitHub. They are similar to what is used by the Tinkercad, Autodesk Tinkercad. So once you connect the batteries on a breadboard, you again check it. Here there are warnings. Suppose there was no soldering iron in your inventory and you did not buy a breadboard, you forgot to buy a breadboard, you'll actually have to go back to the store, buy the breadboard and come back, so you lose time. If you did not get a 9-volt battery, and at the store, when you reach the store, there is no 10-volt source available to you, that means you have to do with a 9-volt battery. So you'll have to go back to the simulator, redo the whole thing with 9-volt or 10.5-volt, and then come back, right? And once this is successful, that is when you you will actually go and the player is going to submit this to the boss, and at the end of the game they should be able to see their score on a leaderboard, and design is correct, and it shows a leaderboard, right, which we kept initially to save data up to 7 days, or I think 2 weeks. So that leaderboard is not there right now. So this was essentially the learning experience. The second game that we developed was called BJT Rider. The first game is based on the genre of role playing. So you are the protagonist and you have to, solve this major crisis that your company is in. The second one is more of a platformer genre, like you may have seen games like Subway Surfer, where the person just has to keep on moving forward, and there'll be obstacles which you need to overcome, but the essential idea is just to move forward. So this is what this second genre was focused on, this game was focused on. And the learning outcomes, because this is the first level of this game, we wanted to keep it extremely simple. And the learning outcomes from this first round of the game is simply to understand the modes of operation of a BJT, that what is cutoff mode, what is active mode, what is saturation mode, how is the doping done in various layers of a BJT, what is the width of various layers, how does it matter in terms of how much current flows through them. So this was very simple, and these are the learning outcome. This was the team Akanksha and Eklavya who worked on this project. So we wanted to teach BJT. So essentially, we made a simple BJT, common emitter circuit, and tried to show voltage up, like the base emitter junction being forward biased or reverse biased. We try to show that through a physical change in potential. Like change in potential was shown with a physical change in height. Like you have a flyover, or you go up a flyover, or you go down a flyover. If there's a drop in potential, or if there's a gain in potential. And since the player is essentially representing the direction of the current, uh, if there is a if there's a large current that flows, we kept the road to be wider. If there's a low current that flows, we would keep the path to be narrower and rather lightly doped, right? And then again, in the beginning, the concept would be explained, on onboarding of the game would be done. And as the levels would progress, we are still in the process of developing higher levels. But then instead of walking or running, then you could purchase a car with your points and more earn more experience points. So here is a walkthrough of that game. So you have help option, the circuit which you're actually making, so that player can uh, 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 actually go to that link and see what exactly is he trying to learn. Explanation of all the highways or flyovers, like rise in potential and drop in potential. Bifurcations when it comes to junction areas, resistors being represented through loose wires. So players should not touch these wires, otherwise they will lose a life. This is the kind of path that has been implemented by the students, trying to represent the simple BJT circuit, right? Some equivalent circuit information on directions and basic instructions on navigating. So a player starts and the missions are explained to the player. They'll be called NPN achiever or PNP achiever. Some instructions and controls. The player will starts with the four lives, and as they make mistakes, each life gets deducted. At the end, if you lose all four, game is over. You have to start over. Right. So the player, you can also see a map view. So you have to escape. You should not touch this. So you can jump over or you can navigate around it. Complete these obstacles. Keep moving. This is starting at emitter. You turn around and you are reaching a junction. A few more obstacles. When it comes to some crucial places like a base emitter junction, or collector base junction, it's going to ask you some questions, and you need to answer them correctly to move forward. Otherwise this gate will not open, right? So you've reached this base emitter junction. So there'll be a question, you can take a hint to move forward. The gate then opens, and this essentially is the place where you need to decide whether this was PNP or NPN. Should I take the upward path or the downward path? Because base emitter will be forward biased through a rise in potential or drop in potential. That depends on whether it is PNP or NPN, right? So this is very simple. Few more questions like that, and the person at the end should be able to see their leaderboard score. This is how we targeted the 8 motivational drives in both the games, the 8 drives, and the elements essentially how that were used to target each of these drives are shown here. I'll not go into the details of them in the interest of time. And when it came to theoretical validation, we used the Octalysis framework again to find out uh, how each of these drives were how to what extent were each of these drives targeted in our games. And this is a score on 800. I should inform you, this is not a very good score on 800 yet. In the overall feedback, what it says was that the experience is fairly balanced between white hat and black hat. But when designing the game, we should be more careful that if extrinsic motivations, if they are not designed correctly, if they are not giving a very good experience, then that can actually kill intrinsic motivation. We went ahead, and this is the feedback from the student on Circuit Maverick. BJT Rider is still, we are still awaiting the feedback from the student, but we kept it open to even school students during our institute open house last year. And a lot of school students, like even middle school and high school students, came, and they seemed to really enjoy playing the game. They could not complete the game, of course, but they seem to enjoy playing it. And in terms of visual appearance, we need a good rework, because of course our students are engineering students. They do not have very good exposure to UX or UI. They have designed a good UI, but the UX part, the experience part, still needs work. In terms of ease of playing the game, a lot of students said regarding Circuit Maverick that they would actually appreciate having a tour of the game, which was missing, and many students could not complete the game. But for rest of the factors, like if they helped in understanding real world application, how useful it would be, and did it actually help in checking your ability to do this in real world, they gave a high score to this game. And we are trying to develop higher levels of the BGT rider and teach how to make load lines and how to make big amplifiers or inverters. That is still in progress. And the work jointly done by these two groups, these two games, actually won the best presentation award at IEEE ICIT in 2022. Now, coming to some challenges that one may face in game-based learning is defining correct learning outcomes. We get very excited many times by thinking about games, but if the game is not, at the end of the game, some learning doesn't happen and it is not measurable, then the game serves no purpose. Another very important aspect is the design of the storyboard and how the story progresses, what you want the student to actually focus on. You don't want the student to learn processes, because processes they've already learned in classroom. There's no dearth of information online or through video lectures today that they do not have that information. But how to use that information in terms of an experience, or like from an aspect of experiential learning, that is where storyboard design is very important. There are many, like I said, there are many games with excellent graphics, but they fail miserably, or rather people stop playing those games simply because the experience of going through the process is not satisfying, it is not exciting, and they give up after some time. Um, in today's time, where AR, VR, and immersive environments, metaverse is taking over a lot of the aspects of everyday life, and of course, it has a very huge future in education. How to bring in a three-dimensional experience to the student is also a big challenge. How to, for example, recreate a basic electronics lab which is interactive. Like, we already created a 3D tour of our basic electronics lab where students can walk around and they can actually it's a VR enabled walkthrough where people can walk around and they can see what are different equipment kept on the table, but to interact with them with those elements and actually create a circuit, make it more interactive, that is where the challenge comes in bringing in a real world 360-degree immersive environment. And of course, most of the tasks today would not be solo. In industry, people will not be solving this question alone. So bringing in a multiplayer experience where a team of people can join together and work at the same time, bringing multiplayer experience is also another challenge in game based learning. And of course, uh, not every game is going to work, but as long as the learning outcomes are correct and crisp, and there is a good balance between these motivational drives that I talked about, the chances of a game failing miserably are very, very less. But of course, there'll be people who like a game and there'll be people who do not like a game. So that, of course, aspect remains there all the time. But it does bring a very exciting flavor to the process of learning. And in my personal experience, I would strongly recommend it. But game based learning may not be applicable to all subjects, all disciplines of engineering, or all disciplines of education for that matter. If it works for certain areas, like especially where there are simulations already available, you've gone through the entire pandemic and you know that to conduct certain labs, what simulations are actually helpful and what are totally useless. So from that point of view, you would be definitely a better judge on whether game based learning would be of any use in your course or not. If anybody is starting off in this direction and wants to work in game based learning, here are some good suggested readings which you may find useful. And thank you so much for listening to me and for having me here again. And we have a new center, like I said, and we welcome collaboration and feedback from you all. Thank you again for hearing me out. If you have any questions, I'm here.
Yeah. So thank you, Rajlaxmi ma'am, for this wonderful talk. So now I request to participants, if you have any question or any doubts, so you can ask to her.
Uh, yeah.
Yeah,
I have
Kalyan
a
ji.
question. Yeah. Firstly, Dr. Manish, thanks for organizing this talk. And Dr. Rajlaxmi, again, thank you so much for presenting very interesting work. I'm Dr. Kalyan. I'm Dr. Manish's colleague at the ICT.
Right.
And so I've been teaching computer networks since 8+ years, sorry, and HCI in the last 3.5 years. So I was just looking at the interfaces that you've shown. So, and some of the ratings that you had at the end. So the question that I had was the ease of usage or one metric you had. Was there any way that you measured it, or was just rating on a scale of, let's say, 5 that the participants were asked to?
So the feedback that I showed, that is from the students on a Likert scale of 1 to 5.
Okay.
But
Okay.
there we have taken the recording of the students playing the game so that we can in depth further analyze the movement of the mouse and see where exactly they got stuck and what
Okay.
exactly was the bottleneck in proceeding. So
Okay.
that feedback at this point that I showed is from the students directly, and how
Okay.
comfortable they felt in moving forward, and they did not feel very
Okay.
comfortable. That's the feedback.
Okay. 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 And the other question is, did you come across any game-based learning for any other courses? Yeah, you mentioned that not all courses would be, easy for developing games, but like for example, anything in networks, or because I remember reading one paper long time back, maybe cybersecurity. There was a game-based learning for cybersecurity where students were given puzzles kind of a thing to, solve a particular concept, understand a particular concept. So did you come across anything similar of that sort?
So in the literature, there are papers, especially from programming courses, which
Mm-hmm.
use game-based learning abundantly.
Okay.
Otherwise, there was another course on sustainability education
Okay.
where carbon footprint calculation of carbon footprint for K-12 students, there are like more than 30 plus games available online
Right. Right.
to
Yeah.
teach them about solid waste management, how to
Okay.
segregate waste. We,
Yeah.
in fact, we are currently working on a game with mechanical engineering students. They have a course called solid waste management, where there are multiple steps, right? Like composting, segregation, landfill, and
Yeah.
something else. So,
Mhm.
how exactly the technicality of each of these steps work
Correct.
in the classroom, it becomes, I won't say it becomes boring, but to give them an experience of what steps should be followed, that is another
Yeah.
one such
Right.
game.
Oh, that would
Been
really
very
fall into
helpful.
that game-based thing. Yeah, segregating items and things. Right. Okay. Yeah. Thank you.
But
And
for that matter, like even communication, like if you have a storyline, something like you are on a stranded island, right, and you have these components, and you need to make a radio out of it.
right.
That again becomes another application, another experience altogether. But
Okay.
then again, for every game, what is important is a subject matter expert is needed,
Right. Absolutely. Yeah.
who actually designs that this is the correct path, this is how it should be validated. It should be applicable more into those areas, like I said, where simulators are available.
Yeah.
uh,
Yeah.
but of course, storyline is like storytelling can be used in any discipline.
Correct. Correct. Yeah. Okay. Thank you so much.
Thanks.
Thank you, Dr. Kalyan. So is there any other question for maybe other participants?
Hello.
Yes.
Yeah, myself, Dr. Rohit Thanki. Uh, I have one question to ma'am. Ma'am, this means publicly available means game, or it is only developed for the IIT student? Means you have.
So right now it is only for IIT students, but once the testing is completed, we plan to make it available to everybody on IIT Jodhpur website.
Because is it means can be help to other student also.
Certainly.
Yeah.
Once the testing is completed and we fix all the bugs and we improve the experience of the flow, like ease of understanding, then we'll make it available to everyone.
Yeah.
Okay. So thank you, ma'am. On
Thank
behalf of IEEE Gujarat section and IEEE Signal Processing Society Gujarat section. So before moving further forward, first I request to all the participants, please open your web camera so that we can take one group photograph. Thank you, everyone. And thank you, ma'am, for your wonderful talk on this particular game-based education. As you have said, that is the very controversial topic. I totally accept that, because parents now, in our scenario as well, nowadays parents are not preferring to play game to the student, and they are focusing that he every time works on the particular course and works on the particular syllabus and other things. So if anyone can get the idea how we can learn the things, how we can learn the electronics and the other things with respect to gaming technology, that will be a very wonderful scenario for the future work. And we are hoping that whenever your particular software will be completely developed, then we will try to use that one for our scenario also.
Sure,
And
thank you.
just as a token of appreciation from our side, just so is screen visible?
Yes.
So this is just one small e-memento, because this is the online talk, so we are just giving the e-memento from our side. So
Thank you.
just one memento from our side. So now I am handing over to Professor Hardik, so you can speak something.
Yes, on behalf of IEEE Gujarat section and IEEE SPS chapter, we are very much thankful to you, madam, for giving very thoughtful and very innovative things for our students and for professional also. Because every time everybody is required some point of some link, some initiation, some new idea which will help all the students and the new professionals in this domain. So in this regard, we are very much thankful to you, ma'am, for giving us idea or thoughtful process in this domain also, that how the gaming can be helpful in the engineering education. And under the umbrella of this IEEE, we are getting very good chance to gather and also to cooperate for